Hello guys and welcome back to this channel. Today we are looking into a series, so a sequence which is defined as a series, and we are asking ourselves whether this series is converging, and if it is converging, what is the value of this infinite sum. So there's a little trick we can apply, and then with this trick we'll see that this sequence actually is a telescoping sequence for which we can in turn apply a very interesting and commonly used trick in order to get a result. So let's first note down that 1 over n times n plus 1 is the same as n plus 1 minus n over n times n plus 1. It's actually the same because in the numerator we just added 0, which is n minus n. So we can look at this bracket in the following way. We can have n plus 1 over n times n plus 1 minus n over the same denominator here. So let's write it down. So this is the same as n plus 1 over n times n plus 1. A common rule you know from school. And then we have minus n over the same denominator, n times n plus 1. And here we can cancel out n plus 1 in the first term and n in the second term, so that we get 1 over n minus 1 over n plus 1. And now we can insert this, the right hand side, into our series. So this series becomes the sum from 1 to infinity of 1 over n minus 1 over n plus 1. So let's write this infinite sum in a different way. We have limit where m tends to infinity of the sum from n equals to 1 to m of, again, 1 over n minus 1 over n plus 1. And by writing this out, you will see an interesting property of the so-called telescoping series. So we have the first addend, which is 1, and then we have minus 1 over 2. So this is the first addend of our infinite series. And then we have plus 1 over 2, minus 1 over 3. Let's continue here, plus 1 over 3, minus 1 over 4, and there you can see a pattern. So the first term stays here, but the second term cancels out with the subsequent term, and the same holds true for all the subsequent terms you have. So minus 1 over 3 cancels out with the subsequent plus 1 over 3, and the same happens for 1 over 4. So if we continue with our sum, we eventually arrive at 1 over m minus 1 over m plus 1. But this plus 1 over m cancels out with the preceding minus 1 over m, which is here somewhere. Yeah. So actually this whole sum is just the limit where m tends to infinity of 1, so the first term, minus 1 over m plus 1, the last term here, which also didn't cancel out. And here it's actually very easy to see that the second term here, 1 over m plus 1, goes to 0 if m tends to infinity. So for this reason, the whole term tends to 1. Which means our original series is convergent indeed, and the value of the whole sum is exactly 1, meaning the series is converging against 1. So I hope this video was useful to you. If yes, please consider subscribing to this channel. This will really help out the channel growing in the future. Please leave a comment, hit the like button, stay tuned for more videos like this. Bye bye!